Ready to uncover the biggest challenge of our time? Dive into the shocking truth about climate change, discover its devastating effects, and see the innovative solutions that could save our planet. Let's explore how we can make a difference together. Hey everyone, welcome back to The Explorist. Today we're diving deep into a topic that's not just trending but crucial for our future climate change. We'll explore the hard science, the visible effects, and the innovative solutions people are working on to tackle this global challenge. So buckle up, because this is going to be a comprehensive journey through the science behind climate change. Let's kick things off with the basics. What exactly is climate change? It's not just about the weather getting hotter or colder. Climate change refers to significant and lasting changes in the global climate patterns over long periods. This encompasses shifts in temperature, precipitation, wind patterns, and other indicators. Essentially, it's the long-term alteration of temperature and typical weather patterns in a place. To understand this, we need to dive into the greenhouse effect. This is a natural process where certain gases in the Earth's atmosphere, like water vapor, carbon dioxide CO2, methane CH4, and nitrous oxide N2O, trap heat from the sun. Without these gases, our planet would be too cold to support life as we know it. But here's the kicker: human activities, especially since the Industrial Revolution, have significantly increased the concentration of these greenhouse gases, enhancing this natural greenhouse effect. It's like turning up the dial on a thermostat. One of the major drivers of climate change is the increase in greenhouse gases. CO2, primarily from burning fossil fuels for energy and transportation, is the most significant. Methane, which is more potent but less abundant, comes from livestock, agriculture, and waste management. Nitrous oxide, another potent gas, is released from agricultural and industrial activities, as well as during the combustion of fossil fuels and solid waste. These gases don't just dissipate, they stay in the atmosphere, creating a thicker blanket that traps more heat. So what evidence do we have that climate change is actually happening? Let's break it down with some hard facts and data. The first and most straightforward evidence is the increase in global average temperatures. According to NASA and the National Oceanic and Atmospheric Administration (NOAA), the Earth's average surface temperature has risen by about 1.18 degrees Celsius since the late 19th century. This might not sound like much, but it's enough to have profound effects on our planet's climate systems. The last few decades have seen the most rapid warming, with 19 of the 20 warmest years occurring since 2001. Scientific consensus attributes this warming trend largely to human activities, particularly the burning of fossil fuels. The Intergovernmental Panel on Climate Change (IPCC) has stated that it is extremely likely that more than half of the observed increase in global average surface temperature from 1951 to 2010 was caused by human activities. Next, let's zoom in on the polar regions. The Arctic is warming more than twice as fast as the rest of the world, a phenomenon known as Arctic amplification. As a result, we've seen a dramatic decline in Arctic sea ice, according to the National Snow and Ice Data Center (NSIDC). The Arctic has lost nearly 13% of its sea ice per decade since 1979. This melting not only raises sea levels but also disrupts local ecosystems and weather patterns globally. Greenland and Antarctic ice sheets are also losing mass. NASA's Gravity Recovery and Climate Experiment GRACE satellites have documented significant ice loss from these regions. Greenland alone lost an average of 279 billion tons of ice per year between 1993 and 2019, while Antarctica lost about 148 billion tons per year. Sea level rise is another critical indicator of climate change. The two main contributors are thermal expansion. Water expands as it warms and the melting of ice over land. The global average sea level has risen about 8 inches since the late 19th century. This might seem small, but it has serious implications for coastal communities, increasing the risk of flooding, erosion, and storm surges. Areas like the Maldives and small island nations are particularly vulnerable. Even in large coastal cities, rising sea levels can inundate vital infrastructure, affect freshwater supplies, and displace communities. The link between extreme weather events and climate change is becoming increasingly clear. We're experiencing more frequent and severe weather events, from hurricanes and typhoons to heat waves and wildfires. The warmer atmosphere holds more moisture, leading to more intense rainfall and storms. Meanwhile, prolonged heat waves and droughts are becoming more common, exacerbating water shortages and agricultural challenges. For example, the Atlantic hurricane season has seen an increase in the number of high-intensity storms. Similarly, regions like California and Australia have experienced unprecedented wildfire seasons, fueled by higher temperatures and drier conditions. All right. Now that we've established the evidence, let's delve into the impacts of climate change. These effects are widespread and affect every corner of our planet. One of the most visible impacts is on ecosystems and wildlife. Many species are struggling to adapt to the rapid changes in their environments. For instance, coral reefs, which are sensitive to temperature changes, are experiencing bleaching events more frequently. When water temperatures rise, corals expel the algae living in their tissues, causing them to turn white and, if the stress continues, potentially die. Beyond the oceans, we're seeing shifts in animal migration patterns and changes in breeding seasons. Some species are moving toward the poles or to higher altitudes in search of cooler climates. These shifts can lead to mismatches in food availability and other critical life events. Putting many species at risk. Human health is another area where climate change has significant repercussions. Increased temperatures can worsen air quality, as higher heat can elevate levels of ground-level ozone, a harmful pollutant. This exacerbates respiratory conditions like asthma and can lead to increased hospital visits. Moreover, climate change can influence the spread of infectious diseases. For example, warmer temperatures and changing precipitation patterns can expand the habitats of disease-carrying insects like mosquitoes, increasing the risk of diseases like malaria and dengue fever. Heat waves also pose a direct threat, particularly to vulnerable populations like the elderly and those with pre-existing health conditions. Climate change isn't just an environmental or health issue, it's also an economic one. The costs of responding to natural disasters, such as hurricanes, floods, and wildfires, are rising. The damage to infrastructure, homes, and businesses can run into billions of dollars. Agriculture is another sector heavily impacted. Changes in temperature and precipitation patterns can affect crop yields, leading to food shortages and higher prices. This is particularly concerning in regions where people already face food insecurity. Additionally, as sea levels rise, coastal industries, including tourism and fisheries, face significant threats. Speaking of food and water security are also under threat. Droughts and changing precipitation patterns can reduce freshwater availability, affecting agriculture and drinking water supplies. In some areas, saltwater intrusion into freshwater systems due to rising sea levels further compounds these challenges. This can lead to competition over resources, potentially sparking conflicts and migration. Communities dependent on agriculture and fishing for their livelihoods are particularly vulnerable, as they face both immediate and long-term threats to their ways of life now. Let's shift gears and talk about the causes of climate change and what can be done to address them. The main drivers are well known, but tackling them requires coordinated efforts at multiple levels. The biggest culprit is the burning of fossil fuels, coal, oil, and natural gas for electricity, heat, and transportation. This releases a large amount of CO2, which is the most prevalent greenhouse gas emitted by human activities. In 2020, for example, the United States alone emitted about 4.6 billion metric tons of CO2, with 79% coming from fossil fuel combustion. To address this, a major transition to renewable energy sources is essential. Solar, wind, and hydroelectric power are all viable alternatives that produce energy without emitting greenhouse gases. The technology for these alternatives is improving rapidly, making them increasingly cost-competitive with traditional fossil fuels. Another significant factor is deforestation. Forests play a critical role in absorbing CO2 from the atmosphere. When trees are cut down, not only is this carbon-absorbing capacity reduced, but the carbon stored in the trees is also released into the atmosphere. It's estimated that deforestation contributes about 10% to global greenhouse gas emissions. Efforts to curb deforestation and promote reforestation are crucial. This includes protecting existing forests, especially tropical rainforests, and restoring degraded lands. Sustainable forestry practices and reducing the demand for products that contribute to deforestation, such as palm oil and beef, are also key strategies. Industrial activities, such as cement production, chemical manufacturing, and metal refining, also release significant amounts of CO2 and other greenhouse gases. These processes are often energy-intensive and rely heavily on fossil fuels. Addressing emissions from industry involves improving energy efficiency, switching to cleaner energy sources, and developing new technologies. For example, using low-carbon materials and processes in construction can significantly reduce emissions. Additionally, recycling and circular economy practices can minimize waste and reduce the need for energy-intensive production of new materials. So what can we do about it? The good news is there are solutions, and they're already being implemented around the world. Let's take a closer look at some of the promising strategies and technologies that are making a difference. Transitioning to renewable energy is one of the most effective ways to reduce greenhouse gas emissions. Solar and wind energy have seen remarkable growth in recent years. Solar panels convert sunlight directly into electricity, and wind turbines harness wind power to generate energy. Both are clean and increasingly affordable options. Improving energy efficiency in our homes, businesses, and transportation systems can also make a big difference. This means better insulation, energy-efficient appliances, and fuel-efficient vehicles. Another promising area is carbon capture and storage (CCS). This technology captures CO2 emissions from sources like power plants and stores it underground, preventing it from entering the atmosphere. And let's not forget the power of individual actions. Reducing our carbon footprint by conserving energy, recycling, using public transportation, and supporting sustainable products can all add up. Of course, we need strong policies and global cooperation to make these changes on a large scale. The Paris Agreement is a great example of countries coming together to set targets for reducing emissions. Before we wrap up, let's talk about how you can get involved. It's easy to feel overwhelmed by the scale of the problem, but remember, every action counts. Educate yourself and others about climate change. Support policies and leaders that prioritize the environment. And most importantly, be an advocate for change in your community. Together, we can make a difference. That's all for today's episode on the science behind climate change. If you found this video informative, don't forget to like, share, and subscribe to The Explorist for more engaging content. Hit the notification bell so you never miss an update. Let's spread awareness and work towards a sustainable future. See you next time.